Hi, this is Michael Ellis. I just wanted to discuss this um, invention I recently came up with. Now it's basically it's a relay motor. So it has this um, uh, uh, what's the word? This mover. Can't think of the word. Anyways, it's a contact basically. So when it hits the upper contacts, it closes the circuit between these two prongs or contacts. Anyways, they're flat rectangular contacts, and as you can see, illustrated here, between the two contacts, it it basically makes the circuit. It's a make or break circuit. So when it moves up and hits the contacts, it closes the circuit. So it's basically a relay like that. And on the side, you can see it has these windings that make the coil. So it's basically a solenoid. So as it moves up, it creates the contacts. It might create a spark or whatnot. But anyways, in this case, it's a good thing. Because as you can see over here, we have it put into a nichrome wire to create heat, basically. That's why we use the nichrome over here. And so as it moves up, closes the contacts, the wire goes across, and it closes the circuit to the coil of nichrome, and our 9-volt battery over here closes the circuit with the nichrome and the battery and everything, and it heats the coil or activates the coil. The mover then becomes it deactivates the coil once it closes the contact, falls down, activates makes the other contacts, activates the coil with the battery and the nichrome, or maybe not the nichrome, I don't know, and I don't know, this schematic is kind of hard to read, and is moved back up again till it makes the contacts. So I don't know. You can set it up either way. But you want gravity to work in your favor, anyways. So when it makes the upper contacts, it deactivates the coil, or actually you can set it up. Actually, I take that back. You can set it up with mirror circuits. So it's going one way. The solenoid is going one way. You just use the right hand rule, that they teach you in electronics school, so that the solenoid is activated in one direction. The mover, the magnetic field moves the mover in one direction, because this is basically a lug of steel, which is magnetized by the coil and the magnetic field, and then has these gold end caps for making the relay contact. So it's magnetized in one direction until it makes the contact, and as it is released, it's magnetized in the other direction, or as it contacts, it's magnetized in the other direction, pulls it down to the other contacts. So you can set up the circuit like that, where it just goes one up and down, one way and the other. It's just the initial momentum that moves the mover, the magnetic pull, anyways. So as it contacts, it releases or it makes the circuit to move it one way or the other. And as you can see, we have the battery over here that's hooked up to the circuits. So you could have like a transistor or diode or something. But the idea is we want it to be as minimalistic as possible. So we just have it directly wired to the Nichrome coil. And we have the coils themselves wound to the contacts in a relay fashion. So you're getting the energy one way when one contact is made, and another way once the other contact is made. And it moves up and down just off that initial push once the contact is generated. So that's basically how it is hooked up. It's impossible to see. This drawing is horrible. I'm sorry about that. But you kind of see though. I tried to make the wires different shades, but that ended up messing them up, and obviously made a mistake here. But you can kind of see the wires kind of through here. This one goes to the battery and coil, and this one goes to the ground here. This battery, this one doesn't go to the battery actually. This one goes to the battery to the, I don't know where that goes, to the ground maybe. And the ground coming down through here. This one, the coil, goes to the over here to the other end of the coil, or no, the contact actually goes through the contact, and this contact goes up in here, and I don't know. And then we have a diode somewhere in there. I don't know where this goes. Down and around. I don't know. This drawing is horrible. I don't know. Well, it's just a basic idea. You have some throw some diodes in there to capture the back EMF, and you might have something interesting. Just saying. Like and subscribe. Thank you for watching. This is Michael Ellis.